Thank you for being here today at Everyday AI. It's really exciting to have everyone together in one room talking about how we're going to shape the future, especially in the era of Gen AI. So my name is Chad, and I'm delighted to be here today to talk to you about the architecture paradigm that can help bring what Catalina spoke about to life. So Catalina just gave us an incredible vision of LLM-powered applications in the enterprise. Now let's take that a step deeper into some of the architectural considerations which we're gonna have to have if we want to make that vision actually happen. So to begin, let's just recap and take a look at the two main takeaways from the previous talk. So for one, we remember that we saw how LLM-powered applications can work and how they look inside an analytics-generating chatbot. And we also understood that in order to stay ahead of the competition, you are going to need to build many such applications. So let's think about this from an architecture perspective. What are the components that you're going to need to build with? Let's set up a taxonomy with 4 layers: the data layer, the services layer, the logic layer, and the application layer. First, you have your corporate data, structured and unstructured. This is what you're going to need to build your LLM-powered applications to differentiate them from your competitors. But down here at the data layer, we're also putting LLMs themselves. Here, we mean the actual models, what might have terabytes worth of parameters. So using, this thing, didn't know that this could scroll. You guys didn't tell me that. So using these LLMs requires hosting them in a service. Sorry, it's not scrolling anymore, guys. All right. So using these LLMs requires using them in a service, so we move up to the services layer. You can host these yourself, or you can host them from a cloud service provider, or you can use the hosted services from one of the model developers. Also, at the services layer, you have the retrieval services. And these are services that, using the same LLM technology, allow you to look up unstructured data. So you can think RAG, but that's not the only time that we're going to use it. And then you have traditional services like data querying services, like SQL databases, and any number of API services. And these last 2 services are considered tools in these LLM-powered applications, because they will be used by the LLM systems to accomplish some task. This is in the logic layer because it defines what is possible by the application. The same goes for prompts, and everything comes together in, as Catalina just said, agents. So this is a new object in the enterprise IT landscape, but a very important one. It's where the business logic for an AI-powered application is designed. Finally, all of this is exposed to the end user in, you guessed it, an application, which includes its user interface, reporting capabilities, and so on. So as you can see, there are some common components and elements with traditional applications, but many new elements as well. So now, as an enterprise, imagine that you want to build many of these applications. In this case, it's important not just to think about the architecture of any one application, but the architecture paradigm of how you might build all of them. Let's think about traditional applications and the architecture paradigms that have been used to develop and maintain them in the enterprise across the years. So it started with the monolithic application. Here, all of the application capabilities were coded directly into the application itself. It was all there, from authentication to data querying to data transformation and display. It all happened in that big monolithic block of code. But over time, organizations realized that this was inefficient and overly complex. We moved to a service-oriented architecture, or an SOA. The SOA was popular for a while, using XML and web services to break up the application monolith. And in recent years, we've gone a step further with microservices. Today, the standard paradigm is to use the JSON format to pass data back and forth between microservices and usually running on Kubernetes. It's great. It's greatly simplified application development, and we're all better off as a result. So what's the current paradigm for building LLM-powered applications in the enterprise? Well, today, we're generally building LLM-powered applications by a monolith on top of packages like LangChain. But it sounds way cooler because we call them chains. Now look, this is a great way to experiment with LLM-powered applications. It's fast, you can get really cool results, and it helps us think through these new applications and what they're capable of. Ultimately, it's a very good thing. But it's not what we're going to be doing in the future. The most successful companies will not be doing that years from now. So you remember how many applications we're going to need to build, right? Let's remember what one application can look like. So here's just one potentially very simple application, and let's zoom out and start building. And I'll even join you. We can all build together. So we have our one application here, but we want to build an agent with a different service. So then maybe we'll want to start reusing some of these prompts over here since they work so well over there. And that gives another team a good idea for an agent and an application. And what's cool is we're going to use the second agent to do. You see how it's a mess already, right? You see how it's an LLM mess already. It's out of control. Not only is this ugly, but it's difficult and potentially risky. Like, literally, look at that. That's awful. So the truth is that any organization can only maintain so much complexity. Some organizations are better than others, but every organization has a threshold beyond which it cannot develop or maintain more applications. So let's think about this as a simple graph where you have the number of LLM-powered applications on the x-axis and the total complexity of building and maintaining these applications on the y-axis. Complexity goes up over time, and it probably follows something more like an exponential curve. And with each new application adding more complexity to the overall suite of applications, we can imagine that an organization's starting threshold is somewhere around here, which means that they can't build any more applications than that. The thing is, there are ways that an application can raise its complexity threshold. And by raising its complexity threshold, an organization is able to develop more applications and deliver more value from AI. And to do that, we need to shift the architecture paradigm. We need to think differently about how to build not just one application, but how we build all of our LLM-powered applications. Similarly, with the shift from the monolithic architecture to services-oriented architectures, the key here is abstraction and standardization. So this new architecture paradigm for LLM-powered applications in the enterprise is the LLM mesh. An LLM mesh has three main principles. First, an LLM mesh provides an abstraction layer through the LLMs and the related services that can be accessed. This standardizes the interface with all these different services so that you don't need to change anything in your application if you don't want to change the underlying service. Second, an LLM mesh provides federated services for control and analysis. Due to the non-deterministic nature of LLMs, their behavior, performance, cost, all of that is not easy to predict. It's not as easy to predict as those traditional applications that we were developing previously. So, all of the applications that you'll need to build will need these controls on top so we can provide a common shared manner to how we put these into production and ultimately govern them. Third, an LLM mesh provides centralized discovery and documentation for all the components. This is important not only for the end users, but also for the agents who are going to be picking up and using these different tools and components. So, taken together, this is how you go from that LLM mesh that we saw earlier to an LLM mesh. First, you establish your catalog and gateway, where you have access to all the different objects that you are going to be building with. Then you create your federated services for maintaining things like access, content, cost, performance, and relevancy. And with that, you start building your apps in an efficient, modular, and secure way. So what does Dataiku have to do with the LLM mesh? So first, we're writing a book about the LLM mesh, which will be published by O'Reilly in early 2025. And you can already download the first chapter, and more chapters will be available soon. And you're not going to be surprised to hear, but Dataiku's out-of-the-box LLM mesh is part of our platform. This is a core part of our current and future product vision, because we really believe that it's the future of how LLM-powered applications will be built in the enterprise and in the future. We'll be talking more about these capabilities in our roadmap throughout today, so please stay with us, and thank you so much. I'll see you guys later.